Now we're going to move on to figuring out the surface area and volume of some shapes. And, we're going to start with the pyramid. And here's some formulas. And personally, I feel like sometimes the formulas are useful and I feel like sometimes they're not. In this example, the SA, the surface area, equals the area of the base, which is a square, plus half of the perimeter times the slant height, which... I just don't think that's the best way to look at it as far as surface area goes. I like the volume, and I'll use that formula. But for the surface area, the way I look at this pyramid is it looks like I have 4 triangles and 1 square on bottom, right? If I were to sort of turn this around, I have a triangle here that is 9 by 11. And each side is the same, right? 9 by 11. And then at the bottom, I have a square that's 9 by 9. So what I'm actually going to do is I'm going to just figure out what the area of each face is and add it together. I think that's the easiest way to do a pyramid, personally. So the area of a triangle is base times height divided by 2. So I'm just going to get 11 times 9 is 99 divided by 2. And I have 4 of those. And then this one, I have 9 times 9 is 81. So you can see that what we're left with here is something that looks like... So, 99, but it's only half of it, right? So it's base times height divided by 2. So 99 divided by 2, which is, I think, going to be 49 and a half, I believe. Anyways, plus 99 and a half, plus 99 and a half, plus 99 and a half, plus 81. I add all those together, and I get 279. You'll notice, too, I put U squared. If they don't give you units, that just sounds for unit squared. And areas in 2 dimensions, we talked about that a lot this year. You're looking at how much seed you'd have to put in the middle. We're going to talk about volume in a minute. Volume would be, like if you were going to fill this with a liquid or something, how much you could put in, so it's in 3 dimensions. But if they give you centimeters, put centimeter squared for surface area. If they give you meters, put meters squared. If they don't give you anything like... I probably should have put inches squared, but whatever. Inches squared, U squared, I'll live with it. I just want you to know, I want you to know that you know that it should be squared. I feel like I should change that to inches. Anyway, moving along. I'm going to make that same change. Like I said, for volume, it's actually, the formula is 1/3 times the base times the height. And I will say that... I think this formula is great. The problem is, if I look here, I don't know what the height is. Like, I know the slant height is 11. And the difference between slant height and actual height is kind of like the following. Imagine you have an 11-foot ladder. If you stand it straight up, it stands 11 feet tall, right? I mean, obviously. But that's not how ladders work. You typically lean a ladder against a wall. Well, this is an 11-foot ladder, but it might only be 8 feet high because you've slanted it. So again, slant height is the actual length of that ladder. The height is how high it is when it hits the wall. So in this example, we're looking here and I'm saying, all right, well, the slant height is 11, but I don't know what the actual height is. But I do know if I look at this thing from the side, hopefully you can see that it's going to turn. If you look at, it's going to turn into a triangle, right? I mean, essentially, I'm gonna cut this 9 in half. It turns into a right triangle. And it's all perspective, and I hope you can see it. But here, I'm going to cut this 9 in half to 4 1/2. I get that right triangle. I know that slant height is going to be 11. And the question is, how high is it? So it's going to look like this, right? I have that slant height of 11, which would be the hypotenuse in this right triangle. I have 4 1/2, which is half of the 9. Now I need to know what's the actual height. And again, that's a visualization thing. I don't know how easily some of you guys are going to be able to visualize that. Typically, I don't know. We talk about leaning against the wall and putting ladders against the wall. And hey, I'm 5'8" when I stand straight up. But if I lean against the wall, now I'm only 4 feet high because I'm, losing some height. So again, it's just sort of a visualization thing that hopefully you guys can see. But long story short, I'm going to go ahead and I'm going to use the Pythagorean theorem again. 8 squared plus 4.5 squared is going to equal 11 squared. Just do the math on that. 4.5 squared is 20.25. 11 squared is 121. Subtract 20.25 from each side. I get 100.75. I take the square root of that, and I get a h of 10.03. So now what I can do is I can go back over into this equation. I know 1/3 That's given in the formula. I know that the base is 81. I already figured that out, right? That's the area of the base. And now I want the height, which I figured out was 10.03. So I can put those numbers in, 81 for the base and 10.03 for the height, and keep working there and keep working until I get the solution of 270.81. And again, I went with a U, and again, I probably should have went with an inch. But you will notice that it is cubed. It is not squared. Areas in 2 dimensions, volumes in 3. So be very careful with that.